Imagine, our Sun has a shadowy companion, a cold, dim satellite that rarely appears in our skies. But once every few tens of millions of years, it plunges its hand into the icy swarm of the Oort Cloud, pushing a cometary squall towards the inner solar system. These comet showers are thought to cause major catastrophes on Earth, mass extinctions, climate change, and global chaos. This very picture formed the basis of the hypothesis known as Nemesis. Let's go back to the 1980s. In 1984, paleontologists David Raup and John Sepkoski analyzed the fossil record and found what they believed to be regular peaks in mass extinctions, occurring approximately every 26 million years. This discovery compelled scientists to search for a cause for this periodicity. Was it interactions with neighboring stars, rhythms in the sun's movement through the galactic disk, or, as one idea proposed, a dark companion to the sun whose powerful yet distant influence stirs up the Oort cloud once every few dozen million years, sending comets hurtling towards Earth? This very idea was formalized in a series of papers in the mid-1980s as the Nemesis hypothesis. Here is what proponents of the idea suggested. Nemesis is either a faint red dwarf star or a brown dwarf, an object intermediate between a planet and a star, moving in a highly elongated orbit with a period of tens of millions of years. At the closest points in its orbit, its gravity could disrupt the stability of the comet clouds in the Oort cloud. A few million years later, we would experience a series of impacts and, possibly, a mass extinction. It sounded logical and dramatic, a scientific tale of an invisible killer. But science doesn't stop at the beauty of an idea. It demands evidence. And this is where the problems began. The paradox of periodicity. The first blow to the simple Nemesis scenario came from statistics. New and improved fossil databases and updated geological timescales showed that the extinction peaks, if they are recurrent, repeat with a surprisingly too precise regularity, for example, 27 million years in some analyses. However, the orbit of a distant companion, subject to fluctuations from gravitational influences like the galactic tide and random stellar encounters, would be expected to have an imprecise period with fluctuations of tens of %. In other words, if Nemesis existed, its strikes on the Oort cloud should be less precise than the geological record indicates. This strengthens skepticism about a direct one star equals regular extinctions link. Astronomical searches, no obvious neighbor. The second problem is a straightforward visual search, but in the infrared spectrum. Modern surveys have not detected anything suitable in our immediate vicinity. The WISE mission, Wide Field Infrared Survey Explorer, scanned the sky in infrared and discovered thousands of stars and brown dwarfs, but nothing that could be confidently identified as Nemesis at the distances where it would need to be to cause regular comet showers. Publications analyzing WISE data have set quite clear limits. Large bodies the size of Saturn are excluded out to 10,000 astronomical units. Jupiter-like objects are excluded even further out. In essence, WISE has severely narrowed the space of possible suspects. The dynamic problem of longevity. The third argument is orbital dynamics. Even if the Sun had a companion billions of years ago, the long-term gravitational interaction with the galactic environment and random stellar encounters makes it very difficult to maintain a stable, long-lasting orbit for such a Nemesis over hundreds of millions of years without significant changes. This means Nemesis, as a constant, perfect clockwork machine, is highly unlikely. But it's not that simple. The periodicity is still debated. The paradox is that some meticulous analyses of updated fossil databases and timescales still find periodicity signals at 27 million or 62 million years quite clearly. These papers renew the question: what exactly is causing these regularities? Some believe the cause could be other astronomical or terrestrial mechanisms. The Sun's passage through denser layers of the galactic disk, waves of star formation, climate changes linked to galactic processes, or internal planetary cycles, volcanism, tectonics. In other words, Nemesis is not the only explanation, and modern research is broadly considering alternatives. Dear viewers, thank you for joining us today. We hope you found this interesting and learned something new. If you enjoyed the video, don't forget to leave a like, subscribe,